Experts explain Africa is splitting in two, and it will look like this. Up close, the process is even more shocking, with a massive crack stretching from Mozambique in the south to the Red Sea in the north. This gap keeps growing every year, tearing apart the land and destroying homes. Now, specialists believe the continent could split much sooner than we expect. Africa is breaking apart because of the Somali Plate movement. Think of it like a dramatic breakup happening with tectonic plates. On the east side, there's the Somali Plate. On the west, we have the Nubian Plate. And during this breakup, the Somali Plate just wants more space, so it's pulling away from the Nubian Plate. This movement is forming the East African Rift, a region where tectonic plates are splitting apart, magma keeps rising from deep below, and a bunch of active volcanoes are being born. So this place is hot, with daytime temperatures that can soar to 130 degrees Fahrenheit, and at night they cool down to 95 degrees. Inside this hot zone, we have the Afar Triangle, also known as the Afar Depression, and its geology is fascinating, as the rifting process is causing valleys, faults, and deep cracks to form in this region. Take, for example, this massive 35-mile-long fissure in Ethiopia's desert. It's also so wide that a person can easily fit inside of it. But what's scary is this crack keeps getting bigger, growing about a half an inch every year. The Nubian and Somali plates moving apart could also lead to a new ocean forming in Africa. This type of process isn't something new. About 150 million years ago, when dinosaurs were still around, a similar tectonic shift created the Atlantic Ocean. The continents were once all clustered together, but when a rift formed in what was Pangaea, it started pulling them apart, splitting the east and west hemispheres. So, a similar thing is happening with this gap in Africa. At some point, experts say the waters of the Indian Ocean might flood the East African Rift Valley, eventually creating a sixth ocean. Now, it's a pity you won't be able to swim in its waters during your lifetime, though. According to geophysicist Ken McDonald, who specializes in tectonic faults, this dramatic rupture could happen in 1 to 5 million years. Trust me, that's considered fast in geologic terms, and way sooner than most experts thought. Now, even though you won't get to watch Africa breaking apart, people there will still see and feel the signs. They might experience intense volcanic eruptions and strong earthquakes as this process slowly unfolds. One example is related to that scary crack in Ethiopia's desert we mentioned earlier. The fissure was created in 2005, after the area was hit by 2 volcanic eruptions and 163 earthquakes, each with a magnitude greater than 3.9. A crack this deep and long on Earth usually takes centuries to form, but in this case, it unfolded in just a matter of days. That's how powerful this event is. In fact, this kind of intense seismic activity can speed up the African splitting process, and that's why it's so hard to predict the exact time frame for the event. What we know is that people are already calling this new land the Nubian continent. If the predictions are right, it will include Somalia, Kenya, Tanzania, and part of Ethiopia. That's exciting and concerning at the same time. As new coastlines emerge, countries will need to make major adjustments when it comes to infrastructure and land management. They might lose a lot of roads, houses, and other constructions currently located near or right in the East African Rift. In Kenya, for example, the fissures tore apart a busy road, and authorities desperately tried to fill the gap with rocks and cement. In another case, an old woman was sitting and eating with her family when her house suddenly split down the middle. Recently, earthquakes that happened near Ethiopia's Afar region demolished 37 schools and forced about 5,000 students to leave their classrooms. Unfortunately, stories like this could become more common over the next few years. But there is a positive side to all this. Countries located in the middle of Africa, like Zambia and Uganda, could gain coastlines, and that might be great for them. Having a coast means they would get access to new trade routes, opening fresh economic opportunities. Plus, think about the tourism boom. With all those newly formed paradisiacal beaches, these countries could become the next big gateway spot for travelers. The local ecosystem in this newly created ocean will change as well, and new marine species may emerge. So let's look. This is the path where the rift is most advanced right now. I mean, we expect this is where Africa will eventually get separated. But things could get a little more complicated. Some time ago, Michael Daly, a geologist at the University of Oxford, suggested that this rift could extend further west. And some new evidence backs up his theory, pointing out that the crack could extend south through Botswana's heartland into South Africa, and west through Namibia, all the way to the Atlantic Ocean. If these fractures widened into deep cracks, the ocean might come in and fill the gaps. Experts say Africa could split so much that it becomes an archipelago. But then again, we won't see that happening. It will take tens of millions of years for this to play out. We already know that Africa is at risk of breaking into a bunch of huge islands, or small continents. The news isn't great for Madagascar either, as the world's fourth largest island could end up being split in half. But can the opposite process happen? I mean, can new land appear as the Nubian and Somali plates move apart? Well, as these tectonic plates get away from each other, the magma from the Earth's mantle might rise to the surface, and when it cools, it solidifies into new land. That's how other places in the world emerged, like Iceland and the Azores. So, yeah, the same process could happen in the East African Rift, and over the long term, it is possible that the rift could create new islands. For now, all we can say is that the geology of the Afar Depression is unique. It is the most active rift system on our planet. And when I say rift system, I mean a zone where tectonic plates are pulling apart. This region brings together all kinds of events, from faults in the Earth's crust to volcanic zones to the potential formation of a sixth ocean. For experts, it's like studying the evolution of rifts up close. And since it is such an active volcanic area, it also has enormous potential for tapping into geothermal energy, that is, using heat from inside the Earth to generate electricity. 2 geothermal power plants are already producing energy in Ethiopia, one in the Ethiopian Rift Valley and the other in the Afar. Now, geologists are exploring new potential spots. When we look at that deep crack in the ground, we know it's caused by tectonic plate movement. There's no mystery there. But what we still don't fully understand is why the cracks happen exactly where they do. For example, a crack that opened up in Botswana appeared after a magnitude 6.5 earthquake back in 2017. But the epicenter wasn't in the rift zone, where the plates are moving like we would expect. Instead, it was farther south. Since it's unusual for a rift to happen without volcanic activity, this fact really challenges our traditional ideas of how continents divide. Figuring out why these cracks appear in specific spots is still a missing piece of the puzzle for experts trying to explain how Africa is splitting. Hopefully, we get some answers before the continent turns into a massive archipelago. So look at this narrow passage between the north of Morocco and the southern part of the Spanish region. It's called the Strait of Gibraltar. There are only 8 miles between the two continents, but for some reason, there's no bridge, despite people having been dreaming for centuries about connecting these two regions. There are places in the world where a bridge over water stretches for a much greater distance. For example, the Lake Pontchartrain Causeway near New Orleans, Louisiana, goes for 24 miles, which is 3 times the length of the hypothetical bridge between Africa and Europe. That's listed in the Guinness Book of World Records as the longest continuous bridge passing over water. It consists of 2 parallel bridges and connects the urban area of New Orleans with small settlements in the north of Lake Pontchartrain. 9,000 concrete piles hold more than 1,000 decks above the water. This large-scale structure was built in the middle of the 20th century. It only took 14 months from the start of construction to its completion. American engineers created a unique technology for attaching concrete piles to the base of the bridge. and this bridge is still functioning. So, what's the problem with building a shorter bridge to connect Africa and Europe? Let's first find out the value of the 8-mile bridge that could connect two continents and the reason why everyone is talking about it. In fact, the value of such a bridge would be enormous. Diamonds, oil, minerals, Africa is full of valuable materials, and Europe is happy to buy these things. This theoretical bridge could allow people to transport things for trade quickly and comfortably. But now, the exchange of goods between Africa and Europe is only possible thanks to airplanes and cargo ships, and airplanes are extremely expensive because of hefty fuel price tags. In addition, air travel is often delayed because of bad weather. There are long customs procedures and transportation from the airport to the destination. Ships can also be a problem. The narrow area of the Mediterranean Sea, where the two continents are closest to each other, is a dangerous place because of storms and strong currents. The transportation of your diamonds is highly dependent on weather conditions. The second advantage of such a bridge would be the creation of tens of thousands of jobs. People from Europe and Africa would build hotels, ports, parks, and even small towns for each other. The coastal parts of both continents would become a new economic center. And just imagine how much investment those places would attract. Europe and Africa would be much closer than ever before. You could drive from a small Spanish town to a safari park in northern Morocco, buy Moroccan tea, get some argan oil, and go home for the evening. Or you could take a high-speed train across the beautiful Mediterranean Sea. People would open hundreds of restaurants, amusement parks, shopping malls, and a museum next to this bridge. But, unfortunately, it's impossible to build such a bridge, at least at the moment. And here's why. The main problem is the Strait of Gibraltar itself, because of its strong currents and seismic activity. How can you start large-scale construction if, in a couple of days, an underwater earthquake can trigger giant waves and take all the ships underwater? Even if you build a bridge, rapid streams of water that constantly change direction can shake the entire structure and tear the connecting parts of the construction. The bridge over the Strait of Gibraltar must have a strong, sturdy system that will withstand seismic activity. Huge resources are required to create such a complex structure. Despite the dangerous passage between the two continents, it remains one of the busiest points in the world. It's the only place on the planet connecting the Mediterranean Sea and the Atlantic Ocean. About 300 ships pass through this area every day. Not only merchant ships, but also fishing vessels and tourist boats. There are not so many places in the world where you can watch whales coming out of the water. Not only people, but also marine creatures often visit this passage because of the peculiarities of the sea currents. But we'll talk about that later. Another problem is the depth of the strait. In simple words, any bridge over the water is built on long metal piles. Builders and engineers stick piles into the seabed and use them as a holding base for the whole construction. But installing such piles firmly enough is a difficult task because of the uneven seabed. The seabed has a unique geological landscape, irregularities, and different densities of the Earth's rock. There are also reefs, rocks, and pits. Any seabed requires extensive geological studies before piles are installed. However, the bottom of the Strait of Gibraltar is especially difficult because of its depth, almost 3,000 feet. It's one of the deepest straits in the whole world. Just imagine, you'll need the height of 10 Statues of Liberty to reach the surface of the water from the bottom of the strait. What kind of pile should be used there to hold the entire bridge? Most likely, one pile will have to consist of several parts connected into one large metal rod. And don't forget about seismic activity. Let's say you've installed perfectly strong piles, but the next day an earthquake occurs and destroys the entire structure. And a strong current is carrying fortifications all over the Mediterranean Sea. The next problem is probably the most important one, because it concerns marine life. The Strait of Gibraltar has a high salt content. This natural element makes water heavier and makes it descend to the bottom of the deep Mediterranean basin. Then, this salt water pushes up cold water from the seabed into the Atlantic Ocean. These changes in water density, as well as fast currents, create sea vortices and turbulence. It's like a raging cauldron of cold water that raises a lot of nutrients to the surface. The hollows and hills of the Strait of Gibraltar are filled with different substances and sunlight, and this creates ideal conditions for the formation of phytoplankton. Whales, dolphins, and other marine creatures adore this delicacy. That's why you can see about 7 species of whales and dolphins in this place. What might happen to phytoplankton after the start of global construction? Carbon dioxide, crushed rock, tons of dust and ashes, falling building materials – all of this could significantly pollute the environment. Without phytoplankton, many fish would go extinct. Without fish, thousands of fishers wouldn't be able to get food and earn money. But even if the bridge was built, cars and trains would continue to pollute the air and water. This disruption of the delicate balance in this narrow strait can lead to larger-scale environmental disasters. Dolphins and whales may leave to look for food elsewhere, and thus take resources from other marine inhabitants. Like falling dominoes, one problem can follow another. And all this because of one bridge. In 2007, the Spanish Ministry of Environmental Protection introduced speed limits for all ships sailing through the strait in order to not disrupt the delicate balance of nature. At the beginning of the 20th century, a French engineer proposed a project of a bridge, but it was rejected because it was too complicated and costly. People also tried to develop a 23-mile-long tunnel, but this project also faced financial and technical difficulties. People are still dreaming of a bridge over the Strait of Gibraltar. Perhaps, in the future, when we develop cooler technologies, we'll be able to build this thing. Oh, by the way, there hasn't always been water between these two regions. In the distant past, the two continents were connected. The entire Mediterranean Sea is the remains of the Tethys Sea that existed before the era of dinosaurs. Then the African and Indian plates collided with the Eurasian one, and the Tethys Sea completely disappeared. In its place, a land bridge was formed that separated the Mediterranean Sea from the ocean. Without access to water, the sea dried up about 6 million years ago. But then, when the bridge came down, the water began to fill the dried-up pool. For tens of thousands of years, the narrow plate sank lower and lower, and the Mediterranean Sea eventually got its current water levels. Wow, this port is so buzzing! Thousands of people come here every day to work, cargoes come and go, fishers are weighing their catches for the day, and even posh cruise ships pop in here to show this idyllic place to all the people on vacay. The ocean shore is fantastic. People walk along the beach eating ice cream or building sandcastles. Oh, and by the way, right now we're standing where the Sahara Desert used to be. Normally our lifetime is too short to see any major changes. We don't notice mountains rise or the way rivers change their course. Entire valleys may be sinking, but it usually takes too long for them to sink entirely. Still, a group of scientists recently noticed there's a new ocean being formed really fast, and we can even witness it appear. Look here! It's the Afar Triangle. There's the Horn of Africa Peninsula not far away. It's the exact site where the sixth ocean is being born at the moment. Wherever you are, you're basically standing or sitting on a tectonic plate. You're just sitting on a couch watching this video? Cool! Your couch is standing on the floor, your floor makes part of your house is standing on the ground, and if you take a deeper look, it all stands on one of 15 principal tectonic plates. Together, these chunks are referred to as lithosphere. It's like a nice apple pie. The crust is the lithosphere, and the fragile apple filling is everything that's on the planet's surface. If the crust cracks, the filling leaks out. And this is what any earthquake is like. A tectonic plate, aka the crust, moves. The filling, also known as houses and people, is disturbed. Africa is made up of 2 plates, the Nubian and the Somali ones. Yeah, that's a large pie. And it seems like these 2 plates are constantly separating. It leads to an oceanic spreading ridge. It looks like the African continent is literally unzipping a part of it at this moment. A 345 square mile chunk of the Sahara Desert just split, so the magma rose. It triggered a series of earthquakes across Ethiopia, Eritrea, and Djibouti. And it's not just some minor earthquake. There are lots of fumes rising from those fissures, and it smells like sulfur. Phew! The eruption slowly pushed the old lava sediments away, which is followed by creation of the new seafloor. The crack is filled with magma, and when it cools, it forms the new oceanic floor. If this process doesn't stop, the Red Sea will finally flood the area, forming the Sixth Ocean, and Africa will be split into two parts. So we'll basically have two Africas. But wait. Neither you nor your grandchildren are going to see that Sixth Ocean. You'll only have 5 of them throughout your life. Same with our future generations. Same old Pacific, Atlantic, Indian, Arctic, and the Southern Oceans. Before the oceanic floor gets solid and before the Red Sea actually starts flowing in there, many thousands if not millions of years must pass. The continents move as fast as your nails grow, and imagine that the longest nail ever seen in history was the thumbnail of an Indian man reaching almost 6.5 feet before he cut his nails. It took him almost 60 years to grow it. Now think how far the continents will have to move by the time you celebrate your 100th birthday. Spoiler, it's not going to be very far. But anyway, you can witness some minor changes that take place even now. All those cracks that may not seem that significant so far make all the landscape in the Afar region look really unique. There's a couple more reasons for this uniqueness. Meet Erta Ale in Ethiopia, the volcano famous for its world's longest-lasting lava lake. It's located in the Afar Depression, also known as the Afar Triangle. By the way, depression refers to the sunken area. There's nothing sad about it. It's not the only volcano in this area. Eritrea, known as the Nabro volcano. It's never erupted, yet the lava in this area is pretty active. More volcanoes are to come because of the tectonic plate movements. They pull away from each other, and the Earth's crust gets thinner. The weaker the area is, the more volcanoes there are. Okay, the plates are separating, and it's kind of inevitable. It's just the question of time. This process is also called the Afar plume. We'll get more volcanoes, it's inevitable either. But how does it happen? Remember that apple pie? Yes, it was delicious. Well, things are actually much more complicated. The outer layer we walk on is relatively delicate and is made up of multiple broken pieces. It's like the eggshell or a lattice top on a pie. Let's take a deeper look at all the ingredients of this pie. If you cut a slice, you'll see it's made up of many parts, and there's something called the asthenosphere under the lithosphere. It's part of the Earth's mantle. Yeah, complicated. So the asthenosphere gets heated from within, and it rises, just like the dough when you put it in the oven. Remember those cracks on the surface of a freshly baked loaf of bread? Man, I'm getting hungry. Anyway, this is basically what happens to the Afar Triangle, and those cracks make this area split, creating those famous rifts and valleys that will possibly become so large and will probably get flooded so that the world's sixth ocean will appear there soon. Or not. Nobody's sure about it. Okay, but since the tectonic plates and, which is logical, all the continents are always on the move, we'll probably have more continents in the future. The answer is yes and no. If a part of Africa does split, we'll get one more continent, which is going to be even smaller than Australia. But there's one more possible way of how things will go. Chances are, in the next 250 million years, in the distant 250 million years, there will be no more transatlantic flights. And a walking trip from Japan to Chile will be possible too. Way too long, but possible. It's all happening now, and the first results will be noticeable in some 50 million years from today. I won't be around then. Australia will move towards Southeast Asia, and it's going to fit in just perfectly. And Africa will be pushed to Southern Europe. Still, these transformations will take a really long time. People and continents have something in common. Remember that continents move as fast as our hair and nails grow, just about 1.2 inches a month. Some of them move even 5 times faster though, But even this speed is too slow for 4,500 miles distance between Africa and Europe. One theory tells us the things we've already seen before. Well, you didn't see that with your own eyes. Neither did any of your ancestors who came to America across the Atlantic hundreds of years ago. The fact is, all the continents were once one landmass known as the Pangaea supercontinent. Even though it formed over 300 million years ago and split about 180 million years ago, give or take, it might come back together. So kangaroos can easily migrate from Australia to the UK if they feel like it, but the latter might be accidentally crashed while all the continents merge together. The Americas would collide, Antarctica would drift to them, and it all will merge with the already collided Africa-Eurasia. In this scenario, one large ocean and one large continent will appear, namely Novo Pangaea. Another possible scenario claims the continents might merge into the uniform landmass or form a circle with a large sea inside and the super Pacific Ocean outside. This continent is referred to as Pangaea Ultima. The third theory might be already coming to life. The Pacific and the Atlantic Oceans might just cease to exist, forming the new ocean basin. Eurasia will be split to form a new ocean, and all the continents will migrate to merge into the supercontinent Orica. And the fourth and last theory claims that the Pacific and the Atlantic Oceans will remain almost unchanged, and all the continents but Antarctica will merge into one, leaving poor Antarctica even more isolated and abandoned than it is now. Nah, don't feel bad. Since all the continents keep drifting northwards even now, it's quite probable that almost all of them will meet up somewhere at the North Pole.
As soon as the Earth is cut in half, almost all living creatures will come to an end. An apocalypse will begin, which has not been shown in movies. The atmosphere is damaged, the magnetic field will change, and the planet's landscape completely alters. But the planet will be completely renewed, and life, like a phoenix, will be reborn from the ashes. A super powerful laser would be needed to separate the planet. Such a laser has to receive energy directly from the sun. The weapon goes into space on a rocket, thousands of miles above our world. Then, once the laser arrives at its destination, it opens wide to expose plates of solar panels. The laser absorbs and concentrates the sun's rays. Then a powerful energy beam with the diameter of several cities shoots into the middle of the planet. Oceans through which the beam passes boil and evaporate from the high temperature. These vapors turn into a vast thundercloud in the sky. A strong wind drives these clouds over the continents. Heavy rain falls, which floods not only cities, but entire countries. As the tectonic plates shift, tsunamis are created. Huge waves crash onto the shore. The Earth is split in two. And this is just the beginning. The structure of the Earth, or rather, each half of it, is changing. Strong earthquakes occur all over the world. The worst disasters happen near the fault line. Billions of tons of ground are smashed. Massive landslides drag entire cities below. Chunks of land, thousands of miles in size, shoot away from our planet. All living creatures on these pieces of land fly into outer space. Other broken pieces of the planet land on the half that is closest to them. Imagine a huge rock the size of a whole city falling from the sky, and there will be hundreds or thousands of such stones. Those who live far from the cut site have a chance to survive, but even there, earthquakes will destroy houses. The moon will also start to throw off pieces from itself. These pieces, like a meteor shower, will fall onto the Earth halves and create massive explosions. These explosions will create fires. The skies will be covered with ash, and until it settles, we won't be able to see the sun. Both parts of the planet are drifting away from each other. The red-hot heart of our Earth is right in the center between the two. This is the Earth's core, consisting of molten metals. Each half of the core exudes energy comparable to a star. Between the two parts of the planet, A layer of such hot space is created that nothing can survive there. Any item that falls into this space immediately turns into ashes. The mass of the core is much larger than the ground mass, so there's a higher level of gravity. The core sucks in everything that comes close. You can't travel from one part of the Earth to the other. The core's gravity attracts any shuttle. Each half of the Earth now lives on its own. Typically, the core inside our planet rotates and creates the Earth's magnetic field. This field is a shield that protects us from the sun and space. If the shield is damaged, solar and cosmic radiation passes through the atmosphere. Because the core is divided into two parts, the Earth's magnetic field becomes unstable. Power outages begin in both parts of the planet. Microwaves, TVs, kettles, traffic lights, computers, everything is broken. The screen of your laptop or phone starts turning on and off. The video may freeze and the battery runs out and charges in 1 second. Satellites stop working, which means there will be no more GPS. High-frequency radio waves used for communication stop working, which means you can't make calls and send texts. In fact, all power plants may sink underground or be flooded because of the earthquakes, so there might not be electricity at all. Some people are sensitive to solar storms and experience severe headaches. When the magnetic field is damaged, the surviving people and animals will suffer from severe migraines. Scientists will have to invent special helmets to protect people from the sun. For full protection, people will have to live in underground cities. Compass needles no longer point north. They just spin in different directions. The birds go mad. They don't know where to fly to wait out the winter because the south no longer exists for them. All animals stop migrating. In the sky, planes can't navigate. Plants and flowers can't grow naturally thanks to the increased radiation from the sun. Livestock are poorly fed. The quality of products deteriorates. There's famine. The main goal for people on each half of the planet is survival. In some places, closer to the fault, the Earth's atmosphere is completely damaged. The conditions there will be similar to those in space. There is no air or heat. Only in a spacesuit can you stay in this territory. Unfortunately, you won't be able to jump and fly because gravity still works. Besides, it's gravity that becomes the salvation of our planet. Both parts of the Earth won't fly away from each other because of the force of gravity. Instead, they will rotate and start to attract each other. In 100,000 years, both parts of the planet will reconnect once more, and the Earth will be completely renewed. Since the core is molten metal, it will return to a single heart, but it will take much longer to connect the solid rock of the halves. A scar forms along the entire fault. The scar will be overgrown with forests and flooded with oceans, but there will be strong earthquakes in some places near this scar. By this time, all living things have probably disappeared. On our planet, conditions are about the same as 4.5 billion years ago. Seas and oceans boil, lightning strikes everywhere, tectonic plates change their shape, and lava flows from volcanoes in a rapid stream. The Earth looks like a vast boiling pot, inside which life is gradually created. Because the Earth has decreased in size and the core hasn't changed much, the gravity will be different. On land, it will be more difficult for an ordinary person to walk. They will weigh much more. In such conditions, new, previously unknown life will be created. Today, the world's atmosphere and oceans are polluted, the population is increasing, and glaciers are melting. In the future, things could be much worse for our planet. In 1,000 years, when humanity has mastered space travel, we may decide to change our residence. We'll start looking for other Earth-like planets, and maybe we'll find something. However, nothing compares to our first home, and humanity decides to cure it. Perhaps we'll come up with the idea to divide the planet in half and live on one side. And after 100,000 years, we can come back to a new healthy home. What if you divide other planets? Since they don't have a magnetic field, they won't be as affected. For example, Venus and Mars have no seas, oceans, or lakes. Some scientists think they're entirely dried up because the magnetic field has disappeared there. This led to the complete destruction of the atmospheres of these planets. The solar wind blew across their surface with such force that it dried up all the liquid. The Earth's atmosphere reflects this wind, so thankfully, we're safe. There would be no significant cataclysms on other planets, except for earthquakes. Like Earth, the two parts of each world would simply rotate until they reconnect once more.
India could split horizontally into two parts as it runs into Eurasia. The movement of the Indian plate that includes most of modern South Asia is causing the Himalayas to grow. This process started around 60 million years ago when the plate first bumped into Eurasia. Scientists from the Netherlands have used the power of an AI simulator to see what this region will look like one day. The computer model showed that the Indian subcontinent will merge with the Horn of Africa in approximately 200 million years. The present-day cities of Mumbai and Mogadishu will become next-door neighbors. They will sit along the newly formed mountain chain scientists provisionally named the Somalaya. On the other side of this geological formation, Madagascar will connect with Sumatra, while Calcutta and the island of Mauritius will occupy the same region. Sri Lanka would cease to exist as it becomes part of the Indian mainland. Further to the north, scientists predict that the Himalayas are going to increase in height in the foreseeable future. As the Indian plate continues to mile northward, there will be major changes to the surrounding landscape. The present fault line will drift further south. Tens of thousands of years in the future, there might be no Nepal. The Himalayan range will have expanded sideways to fully engulf the mountainous country. And there may be way more earthquakes in this part of the world because of this movement. Most researchers agree the speed at which India is moving northward into Eurasia is barely a tenth of an inch every year. Some of them think this is happening because of the plate's buoyancy. It prevents the Indian plate from sinking into the mantle, which gives Tibet its elevated topography. Other scholars believe that the structure is buckling under the pressure. The process resembles what happens to a sheet of paper when you push it horizontally against a wall. As you apply more pressure to its edge, the sheet starts to rise in the middle. In the real world, this bulge would be the Tibetan Plateau. A recent theory gives us the third explanation for the process. Their paper still has to undergo peer review, but the findings are intriguing. The international team of researchers introduced a new concept: the delamination of the Indian plate. This term simply means the separation of layers in a material that is supposed to be bonded together. Think of a sandwich that has cheese and ham slices between two buns. Take one of those layers out of the sandwich and you get delamination. In geological terms, this process involves the upper part of the plate peeling off and moving upwards. In the case of the Indian plate, this is the section that supports Tibet's elevation. The lower section is denser, which causes it to sink into the mantle. Plate tectonics are, in this way, similar to a layered cake. Chefs place the spongy, denser layer at the bottom, so the heavier top doesn't crush it. Scientists developed their thesis by analyzing helium gases in water samples from the region's hot springs. Helium-3 is a rare isotope that shows that the mantle is close to the surface of the Earth. Researchers measured helium isotope ratios at 200 Tibetan springs. The pattern they saw shows how close the mantle is to the northern Tibetan surface. Further to the south, they found plenty of helium-4, another isotope, which means that the plate is intact. It forms a barrier that helium-3 cannot penetrate, except in one region near Bhutan, in the eastern part of the Himalayas. The seismic activity in the region is good proof that delamination, the sandwich theory, is all real here. And it shows us that the mantle is intruding from the eastern side of the plateau. This concept puts under question the old, established ideas about tectonic plate behavior. The scientists behind the study suspect that the unique shape of the Indian plate contributes to the delamination process. It's the thickest at the northernmost point and the thinnest on the sides. If it's all true, it will mean that the continental collisions have a more dynamic and complex nature than geologists previously believed. Scientists still don't have enough hard evidence to prove the correctness of the new theory, just hints. Drilling to depths of over 60 miles is mechanically impossible right now. Such excavations are necessary to be 100% sure that the delamination process is going on. With the right technology, we would be able to better understand the hazards associated with earthquakes in the Asia-Pacific region. It's home to the famous Ring of Fire, where 75% of Earth's volcanoes are located. 9 out of 10 all earthquakes take place here. The India-Australia Capricorn tectonic plate beneath the Indian Ocean is also important for solving Earth's tectonic mysteries. The term geophysicists use for such locations is nascent plate boundary. These are plates where tectonic plates are just starting to pull apart or push against each other. They represent the initial stage of a full-fledged plate boundary. Such a geological transformation unfolds at a pace of barely 5% of a single inch per year. That's about as long as a strand of spaghetti is wide. This shouldn't worry us too much from today's perspective. The India-Australia Capricorn plate is destined to split in half over the course of tens of millions of years. Scientists from France studied records of 2 earthquakes that happened in 2012 and concluded there must be a nascent boundary there. Earthquakes normally occur at places where 2 or more tectonic plates meet. But the tremors in the Indian Ocean happened in the middle of the plate. The scientists used sonar scanning to map out the sea floor and see what was really going on there. After further examination of the marine area off the coast of Western Australia, researchers found a complex network of 62 pull-apart basins along a fracture zone. The scientific data backed up the idea that the tectonic plate was slowly but surely breaking apart. It's another proof that the outer layer of our planet is dynamic, not static. In some cases, you don't have to be a scientist to notice these powerful underground forces. Massive crevices emerged almost overnight due to heavy rainfall in a seismically active region in rural Kenya. First in 2018 and then again in 2023. The local population named the biggest of them the Grand Kenya. These events were not one-time incidents, but signals from the East African Rift System, part of the Great Rift Valley. This huge geological phenomenon stretching from Jordan to Mozambique shows us the gradual splitting of the African continent into 2 subcontinents. You can find rift valleys all around the world as proof of how tectonic plate movements are changing the planet. The East African Rift shows the underlying dynamics of the Nubian and Somali plates. The Nubian plate bears most of Africa, and the smaller Somali plate cradles the Horn of Africa. The 2 are gradually moving away from one another, which causes the formation of crevices within the Rift Valley. This process of continental rifting, going on at a rate slightly faster than the one in India, will eventually lead to the split of Africa into 2 continents. The whole process, which is about to happen in the next 10 to 50 million years, marks a significant geological event that reminds us of Earth's historical transformations. The last time our planet's geography changed so drastically was during the Jurassic period. The world map from the period looks recognizable, but the land masses were oddly positioned from the modern perspective. In the north, Eurasia was still loosely connected to North America, which was at the time called Laurasia. This landmass was slowly moving away from the supercontinent of Gondwana, further down south. It consisted of what we know today as Africa, South America, Australia, and Antarctica. At the time, the Indian plate was closer to Madagascar than to Eurasia, as it is today. At the end of December 2021, an underwater volcano with a rather exotic name, Hunga Tonga, woke up after several years of sleeping. It did that with so much energy and strength that people heard the eruption from over 100 miles away. Then it went back to sleep. But a couple of weeks later, it woke up again with a force 7 times greater than the first time. It broke the island above it in 2 parts. The lightning storm that started because of the eruption was the most intense in recorded history. The sound waves from the eruption traveled around the planet several times. Someone even heard a loud boom from it in Alaska. And it started the first known mega tsunami since ancient times. This tsunami took the lives of 2 people as far as Peru and caused trouble for 2 fishermen in California. But that's not all. This eruption could change the weather patterns on Earth for years. You may see the first proof in the summer of 2024, which is forecast to become much wetter than usual. Scientists believe the eruption was caused by gas building up to a critical point. Different minerals, including anhydrite quartz and sulfides, were building up for several months until they blocked the flow paths and sealed the gas within Hunga Tonga. Normally, when a volcano erupts, the fumes cause a temporary cooling effect on Earth's surface. But Hunga Tonga's eruption was different. It didn't produce much fumes, but released a massive amount of water vapor, roughly equal to 60,000 Olympic swimming pools. The intense heat of the eruption turned huge amounts of seawater into steam, which then blasted high into the atmosphere. All that water vapor ended up in the stratosphere, a layer of the atmosphere that's too dry to form clouds or rain. Scientists don't have any observations of volcanic eruptions like Hunga Tonga to predict its effects on our weather patterns. They can't tell exactly how long these effects might last either. This is because the only way to measure stratospheric water vapor is with satellites, which have only been around since 1979, and there hasn't been an eruption similar to Hunga Tonga in that time. Experts from different countries started analyzing satellite data right after the Hunga Tonga eruption. They wanted to find out how long water vapor would stay in the stratosphere, where it would go, and, most importantly, what this would mean for the planet. The first big result of the eruption, at least partially, was a huge hole in the stratosphere that was hanging on for several months in 2023. By the time it appeared, the water vapor had reached the polar stratosphere over Antarctica. In the following years, there wouldn't be enough water vapor left to enlarge this hole. It looks like Hunga Tonga will have just a minimal effect on global average temperatures. But there are some surprising, lasting regional impacts. One of the scientific models forecasts colder and wetter winters for northern Australia until about 2029. In North America, it predicts warmer winters, and Scandinavia could have even colder winters. This is just one study though, and one approach to understanding how the eruption of Hunga Tonga can change our weather. We do have at least one example from history when a volcano eruption changed the world. Over 2 centuries ago, in 1815, Mount Tambora erupted and caused the year without a summer. In the following year, the winter was unusually cold and wet weather across Europe and North America. A recent study confirms that 1816 wouldn't have been this cold without the volcanic eruption. The immediate effects of the eruption were catastrophic, with tsunamis destroying homes, claiming 10,000 lives, and 80,000 more who fell ill in the aftermath. The eruption of Mount Tambora was one of the strongest in the last 1,000 years. It had ejected an enormous amount of sulfur dioxide into the stratosphere, which quickly spread across the world. It resulted in the coldest year in at least the last 250 years. In May, frost wiped out most of the crops in New York, Massachusetts, New Hampshire, and Vermont. By June, heavy snow covered the ground in Albany, New York, and Dennisville, Maine, and New Jersey had 5 straight nights of frost. The cold continued into late summer, which should have been the harvest season. In July, lakes and rivers were still frozen as far south as northwestern Pennsylvania, and frost stayed in Virginia until late August. Temperatures would drop from above normal summer highs to near freezing within just a few hours. The weather was completely unpredictable. Prices of food skyrocketed. The cost of oats for horses, which were the main mode of transportation, also rose sharply. Some people believe this situation inspired Carl Drees to invent the bicycle in 1817 as an alternative transportation method. Tambora changed weather patterns completely for not just 1, but 3 years. The whole planet got colder, and as crops failed, probably at least 1 million people starved. Scientists don't have solid evidence of volcano eruptions that have taken more lives than Tambora. But the Krakatoa eruption in Indonesia in 1883 is far more famous than Tambora because information about it spread worldwide via telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami with waves about half as tall as the Statue of Liberty. Still, it was less powerful than Tambora's eruption. The island that once hosted Krakatoa disappeared in the eruption, but new eruptions began less than 50 years later and created the Child of Krakatau cone in the center of the caldera of the old eruption. The new volcano still comes to life from time to time. Mount Vesuvius's eruption, which took down Pompeii, is one of the most well-known volcanic disasters in history. It took around 2,000 lives, much fewer than Tambora. According to a famous Roman author of that time, the eruption lasted 18 hours. Pompeii was covered by a layer of ash and pumice that was thicker than twice an average human height. The nearby coastline also changed dramatically. In today's world, the after effects of volcanic eruptions are often more dangerous than the eruption themselves. Thanks to advances in technology, we can now predict volcanic eruptions more accurately and use safety measures like evacuations and flight cancellations. But there's still a lot of risk that changes in weather patterns and drought all over the world, especially in areas like India, East Asia, and East Africa that are affected by monsoons. Volcano eruptions can also have effects you wouldn't probably expect, like the evolution of dinosaurs. These guys were once the size of cats, waiting for their time to shine. It came around 230 million years ago. This time is known as the Carnian pluvial episode. Before it, Pangaea was a dry and arid supercontinent. But then, there were 4 major volcanic events that pumped huge amounts of carbon dioxide into the atmosphere. Global temperatures and humidity spiked because of it. These massive eruptions most likely happened because of the Wrangellia Large Igneous Province eruption in what is now British Columbia and Alaska. This prolonged volcanic activity created the right conditions for dinosaurs to blossom and diversify, and also for the rise of other groups, like modern conifers, ferns, crocodiles, turtles, insects, and early mammals. With higher temperatures and more rainfall, terrestrial plants have evolved, and humidity-loving ones have become dominant. Without those changes in the world, we could have a completely different natural history. There's some solid proof that volcanic activity has really changed the weather patterns back then. Scientists have found layers in the Earth's core that show different types of carbon. It means there were 4 massive releases of carbon dioxide into the atmosphere. The data on mercury and carbon together shows that the spike in mercury levels was thanks to a major volcanic event that affected the global carbon cycle and not just local eruptions.
Our planet has 5 oceans: the Pacific, Atlantic, Indian, Southern, and Arctic, not counting Billy Ocean. But it seems there's a 6th one out there too. It's just that you can't see it. Scientists have found evidence of large amounts of water hidden in the transition zone. That's the boundary layer that separates the upper and lower mantle of our planet. That boundary goes hundreds of miles deep down below the surface. Natural diamonds usually form in the mantle, but at depths of up to 155 miles. Some of them are very rare. They may come from deeper depths. That was the case with this fascinating diamond that formed 410 miles below the surface. The gem was big enough for scientists to study it and determine what it was made of. They were surprised when the composition of this very rare diamond showed that it was formed in pretty watery conditions. Because of that, such a diamond wouldn't be worth much in jewelry stores, but it was priceless in the lab. So, could this mean there's an ocean under the surface of our planet? It would definitely get us closer to the idea Jules Verne had about this whole magical secret world inside Earth, including the ocean. But that's not exactly the case. The water is there, true, but it's not like you can enjoy the view watching waves splashing around like on the surface of our planet. The water is actually stored within the minerals. That's why this area is so wet. Let's now move to Africa to keep up with the story, or to be more specific, to a spot called the Afar region. It's part of Ethiopia and a place where 3 tectonic plates meet. Tectonic plates are large pieces of our planet's crust that slowly move. These movements cause earthquakes and produce volcanoes, mountains, deep underwater valleys we call trenches, and so on. And the Afar Valley is where the Arabian, Somali, and Nubian plates meet. Together, they form an intersection in the shape of a Y. Why? Let me tell you. These plates are moving all the time. The Somali plate is moving southeast toward the Australian and Indian plates. The Arabian plate is moving north, getting closer to the Eurasian plate. At some point, it will close the Persian Gulf. This movement of plates has created something we call the Great Rift Valley, considering there are, all these cool rifts. The Aden Ridge to the east, the Red Sea Rift to the west, the Oculus Rift and the East African Rift to the south. But the East African Rift is something we want to focus on, because this one could be the key to this potential sixth ocean, but this time on the surface. A continental rift is a spot where 2 tectonic plates that form a single continent start to separate. Here it's the Somali and Nubian plates. Together, they're parts that make up Africa. If they keep moving in separate directions, this currently continental rift may become what we call an oceanic spreading ridge. In other words, when the plates are far enough apart from each other, there will be an enormous crack between them. This way, magma will freely flow up from beneath them. It'll be cool and eventually start creating a new ocean floor. Africa will be split into 2 parts, and there will be a new ocean flowing between what will turn into 2 mini-continents. Nope, it's not time to get your swim trunks and sunscreen yet. Even if the Somali and Arabian plates do move far enough to form an oceanic spreading ridge, it'll take millions of years before this happens. So I guess it's more interesting to stick to exploring this 6th ocean below the Earth's surface for now. The idea of subsurface oceans goes beyond the borders of our planet. It's possible many moons and planets out there have them too. Our home planet is the only one we know about with consistent bodies of liquid water on the surface, true. In our solar system, we circle around the Sun in something called the habitable zone. The temperature and atmospheric pressure within this zone allow water to remain in liquid form all the time. But a couple of moons in our solar system could also contain significant amounts of water under their surface. Enceladus, one of Saturn's moons, is the first one. Enceladus is a small frozen ball, 7 times smaller in diameter than our moon, but it's the 6th biggest moon of Saturn. Nearly a decade ago, a spacecraft found evidence that there was a large ocean under its surface. It found and sampled water from the eruptions that resembled geysers. A geyser is a rare type of hot spring that erupts and sends jets of steam and water into the air. Like Old Faithful in Yellowstone. Well, this water was erupting through fissures in the ice at the south pole of the moon. That means there might be a liquid ocean under the thick layers of ice. The ocean there is almost nothing like ours. The ocean on Earth is relatively shallow, on average 2.2 miles deep, and it covers 3/4 of our planet's surface. It gets colder the closer you come to the seafloor, and is warmer if you stay close to the surface because of the sun's rays. But the subsurface ocean on Enceladus is at least 18 miles deep. It's cooler at the top because that part is near the ice shell, and warmer at the bottom because of the heat coming from the moon's core. But both our ocean and the ocean on Enceladus are salty. Enceladus is one of the few places in our solar system that has liquid water, which makes it an interesting spot to search for signs of life. Another one is Europa, one of Jupiter's moons. Scientists think similar eruptions of water could be happening there. Knowing there are such geysers there tells us these moons have their own source of energy. Maybe the energy that makes the water erupt comes from gravity or radiation. The same energy could keep a large body of liquid water under the ice. It could even support some forms of life. There are thousands of planets beyond our solar system that orbit other stars. Some are even in the habitable zone. Over a quarter of the ones that we know about could have liquid water, but the majority of them probably have oceans under their surface, like Enceladus and Europa. Pluto might be on this list too, since it's possible it hides a liquid ocean under its thick frozen shell. This subsurface ocean likely formed long after the dwarf planet did, after the heat coming from radioactive elements in Pluto's core melted some of its ice. There's also something called water worlds. Those are moons or planets with global oceans that are more common than we thought. I mean, some call Earth a water world too. 71% of its surface is water after all. And when you look at our home planet from space, you mostly get those blue marble pictures. When exploring other planets, especially those outside of our solar system, researchers often go with a policy of follow the water. After all, water is the main element we know that's necessary for supporting life. And when there's a water world that's close to its parent star, scientists assume it must have formed way farther and then moved closer once its orbit shrank. The composition of the planet was set when it was in a colder orbit, or, in other words, when it made a wider circle around its star. We call the process of orbital shrinking a migration, and if water worlds are really that common, it can be proof that migration really happens. Exoplanets are all those planets that orbit around other stars, not our Sun. Some exoplanets may have oceans that are way deeper than any of those in our solar system, hundreds or even thousands of miles deep. Our Mariana Trench is scary, and it's not even 7 miles deep. And those exoplanet oceans are, wow, almost bottomless.
The Earth has 3 main layers: 2 parts of the core, the dense, hot inner core, and the molten outer core. Then comes the mantle. And then follows the thin crust, the surface that supports life as we know it. At least, that's what we thought, because now scientists found a new mysterious layer located deep within the solid inner core. Earth's inner core is approximately 2/3 the size of the Moon. And made of nickel and solid iron, it's burning hot. The temperature at the center of our planet is the same as at the surface of the Sun. The outer core can reach almost 10,000 degrees Fahrenheit. It's difficult to explore it because we can't go there, and it's like looking through a really dirty window of 3,200 miles of molten metal and rocks. But we can rely on laboratory experiments on heated pressurized rocks, signals from seismic waves, and computer models. When an earthquake hits, it sends out seismic shock waves. Those waves travel through layers at a different speed, depending on the direction they go and the material they move through. In the new study, a team of scientists set a data set of 100,000 deep earthquakes. Some of them went over 60 miles below the surface. When an earthquake happens on one side of our planet, scientists track its waves all along to the other side. Waves change when they come to the other side, so scientists try to understand the materials these waves have passed through. They found a new layer in the core of our planet thanks to earthquakes. Normally, shock waves travel along the equator, but down below, they digress and go into different directions, about 60 degrees to the side. When waves pass through the inner core going from north to south, they will travel more quickly than waves going through the core parallel to the equator. It's important to understand the core because it creates our magnetic field, which in turn protects the planet from things like solar winds that are charged particles coming from the sun. In the 1960s, we discovered the Earth pulsates every 26 seconds. It's like clockwork, a giant heartbeat. The ground is slightly shaking, but we mostly don't feel it. Researchers can still track it. Some of them think the continental shelf comes as a huge wave break under the oceans. For example, the highest part of the North American continent falls off into a deep abyssal plain. One theory says waves hit this spot, producing regular pulses. It's like having all kinds of drums. You hit them with your hands and accidentally slam that one spot that produces the right harmonic bang to rattle our entire planet. If this theory is true, we're lucky there are no more spots like this that can shake the Earth. Other scientists believe the pulsation happens because there's a volcano near the critical spot, the island of Sao Tome in the Bight of Boni. You're walking, running, and jumping, but when you stop, it always feels like you're standing still. In reality, you're moving even when you're perfectly still because our planet is always on the move. Depending on where you're at, you could be spinning through the universe at more than 1,000 miles per hour. If you're on the equator, you'll move the fastest. Let's say you have a basketball spinning on your finger. Check the ball's equator. A random point on it has farther to go in just one spin than any point near your finger. That means the point on the equator is moving more quickly. The Earth is a planet that recycles all the time. The ground we're walking on is recycled. Our planet's rock cycle turns rocks of one type into another. That's a cycle that goes on and on. The depths of our planet are filled with magma. As magma is going out onto the surface, it hardens into rock. Tectonic processes like volcanic activity, earthquakes, mountain building, and all of the other processes that shape the surface of our planet bring that rock to the Earth's surface. When the rock is on the surface, erosion shapes it and shaves its bits off. Those small particles then get deposited. All the pressure coming from above compacts the particles into sedimentary rocks, like, for example, sandstone. Sedimentary rocks can also end up deeper and deeper under the Earth's surface. Since there's a lot of heat and pressure, they get cooked into metamorphic rocks. They can go back to the surface once again, or even end up being re-eroded. Sometimes the crust plates are pushing one under another, and this way, rocks can transform into magma once again. We've explored only 5% of the ocean so far. The ocean itself, as well as life below the seafloor, is still a mystery. The sediments that are underlying our oceans are home to different microorganisms that exist even at depths of 1.5 miles beneath the seafloor. There are microbes hidden deep inside volcanic rocks below the seafloor off of the parts of the Pacific, hidden under 870 feet of sediment. The biosphere under the seafloor is growing extremely slowly compared to life on the surface. Cell division happens every 10 to 1,000 years. Something's different about the Earth's axis. Climate changes and melting glaciers, mostly in the regions like the Himalayas and Alaska, made the axis shift. Our planet has two kinds of poles. Are the south and north magnetic poles. They affect things such as drift and navigation. The axis that the Earth is spinning around is another kind of pole. It shifted a little bit over time, but we don't know exactly why. Researchers realize there are moving masses of water, pushing the Earth's axis eastward. Take a basin of water as an example. If you're moving it back and forth, sloshing makes the water move its weight all around. A similar thing is happening on a planetary level. No matter how large an earthquake is, no human could ever feel an earthquake on the opposite side of the Earth, although some people claim they did. In 2013, there was one near the Kuril Islands with a magnitude of 8.5. It went around 400 miles deep. It was so strong, people in Australia reported they could feel the ground shaking. The strongest earthquake happened in Chile in 1960 with a magnitude of 9.5. The rupture zone stretched from 311 miles to almost 620 miles along the country's coast. Earthquakes with a magnitude of 10 or higher can't happen. The magnitude depends on the length of the fault where it occurs. The longer the fault, the bigger the earthquake. A fault is a break in a part of the planet's crust. It has rocks on both sides, and they move past each other. We haven't found a fault long enough to generate earthquakes with a magnitude of 10 or more. If it happened, it would extend around most of our planet. An earthquake with a magnitude of 12 would require a fault larger than our planet. One side of our planet is getting colder than the other. The Earth has a system that keeps it warm from the inside, a red-hot liquid interior deep below the surface. It spins and, at the same time, generates a magnetic field and gravity. That way, the Earth's core holds the atmosphere closer to the planet's surface. The Earth also absorbs heat from the sun, mostly on the surface. The heat doesn't spread equally on all parts of the Earth. One side of the planet, the Pacific Hemisphere, is losing heat more quickly than another, the African Hemisphere. This happens because land traps more heat than the surface under the ocean. The seafloor is way thinner than the landmass. Also, the temperature caused by the heat coming from inside the Earth is getting lower because of huge amounts of cold water above it. Clouds are not just like some fluffy distant pieces of cotton. They weigh more than 1 million pounds and help regulate our planet's temperature. If you take all the water droplets in clouds and bring them to the surface, you could cover the planet with a liquid layer as thin as a human hair. It doesn't seem like a lot, but this water is crucially important for climate. We'd have warmer temperatures if it weren't for the clouds.
Do you know how many continents there are on Earth? That's an easy one, 7. But wait a second, aren't Europe and Asia one large continent, Eurasia? It looks so when you look at the world map. Well, scientists think differently. They don't just look at bodies of land sticking out of the sea. Geoscientists study the types of rock that continents are made from. When you see the world from their perspective, the number of continents actually increases. Yes, they are not a myth. Lost continents exist, or at least they used to. They are hiding under other landmasses. Peekaboo! Researchers have recently discovered one continent just like that. It's called Greater Adria. Sound familiar? Yes, it has something to do with the Adriatic Sea. This lost continent is completely buried under Europe. It collided with Europe and started to sink under it a long time ago. Today, it lies beneath Italy, Greece, and the Baltics. Its size and even shape match that of Greenland, the world's largest island. But how did geoscientists find Greater Adria? It's no longer visible, but it left some clues. Parts of it were embedded in the Alps. Other chunks were incorporated into present-day Italy and Croatia, on the other side of the Adriatic Sea. Limestone rocks from the former continent started to change once they were under the European landmass. Tremendous heat and pressure spread over tens of millions of years changed their structure. Out goes the limestone, in comes the marble. All the Greek and Roman temples you admired on your summer vacation were constructed using this marble. It was sort of a going-away gift from a long-lost continent. Greater Adria camouflaged itself well for thousands of years, but other lost continents were hiding in plain sight. Have you heard of Earth's 8th continent, Zealandia? Probably not, because it sits under the surface of the Pacific Ocean. 95% of Zealandia is now underwater. Can you guess where exactly? Its name is a good hint – under New Zealand. If you open Google Maps, you can see its outline. Look for a lighter shade of blue in the ocean. It should stretch from New Caledonia to New Zealand. This bump in the ocean floor used to be above sea level. It was about 2/3 of Australia and more than twice the landmass of Greater Adria in size. We can spot Zealandia today because it hasn't sunk too low, and that's the best way to discover other lost continents. Imagine the Earth without the oceans. The bottom of the sea isn't flat. There are mountains and trenches. You could put Mount Everest in the deepest of them, and there would still be 7,000 feet between it and sea level. This trench got so deep because of a geological process called subduction. The Pacific Plate got under the Philippine Plate. Earth's crust is made out of those plates that float in a sea of molten rock. Then they bump into each other, one goes down while the other one rises. That's how Greater Adria ended up under the European continent. Our planet is constantly on the go. We don't notice this process because it happens deep beneath our feet. 120 million years ago, Australia and Antarctica were a single piece of land. Yep, the coldest and one of the hottest places on Earth were once the same territory. Antarctica said goodbye to Australia, but it didn't leave empty-handed. Today, there is an oceanic plateau in the Indian Ocean. The word plateau comes from French, and it means elevated flatland. And the name of this land sounds like the title of a Hollywood movie, Broken Ridge. Long ago, it was connected to another lost continent. Scientists believe that it made a land bridge between India and Antarctica. What was this land like? The answer possibly lies in a tiny archipelago in the southern Indian Ocean. These islands are all that is left of an ancient landmass. They have a cold climate. The islands feature glaciers because they're so close to Antarctica. But in the past, the climate must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that we find in tropical regions today. The lost continent's landscape probably resembled that of New Zealand. Now, while we're in the area, can you guess which continent the island state of Madagascar once belonged to? If you guessed Africa, sorry, you were wrong. Hey, don't feel bad. Look up and to the right of the map. The correct answer is India. Some 120 million years ago, I wasn't around then, India separated from the African continent and went northeast. Madagascar wasn't quick enough and ended up as an island off the southeast coast of Africa. But there is evidence of an even greater landmass, the lost continent of Mauritius. Scientists found traces of the ancient landmass under the island of Mauritius. Today, it's a tourist hotspot, but millions of years ago, it was a real hotspot, volcanoes and all. That's how scientists were able to retrace the steps of Mauritius. They found a mineral that exists in rocks which lava spews out after an eruption. The long-lost land once covered the area from Mauritius to the west coast of India. Imagine if that land existed today. It would form a great mix of Indian and African cultures. The local dishes would definitely be spicy. Now, speaking of spicy, have you had Indonesian food recently? Just 50,000 years ago, Southeast Asia looked much different. There was no Sumatra, Borneo, Java, or even Australia. Just Sunda and Saul, two continental masses that were divided by a deep water trench. You had the extension of mainland Southeast Asia on one side and the Greater Australia on the other. Back then, Bali stood at the southernmost tip of Asia. Biologists were among the first scientists to notice the split. Species developed differently on Sunda and Sahul. That's why Australia has unique animals, such as the kangaroo, wombat, and platypus. And did you know that a giant kangaroo once roamed the island of New Guinea? That's because, up until the end of the last age, there was a land bridge to Australia. Today, the two islands are separated by the Torres Strait, but it's quite shallow, less than 65 feet. It's a reminder that this was once a single landmass called Saul. Another ocean strait that isn't too deep separates Asia from North America. The Bering Strait sits today in the place of Beringia. This ancient landmass wasn't that big. It stretched 1,000 miles from north to south. That's just a third of the driving distance from Los Angeles to New York. Beringia was important for another reason. During the Ice Ages, it connected the whole world. Water levels were 300 feet lower than they are today. If they went even lower, you could walk from the Cape of Good Hope in Africa all the way to Cape Horn in South America. Talk about the ultimate backpacking route. Today, you can hop on an airplane and fly to pretty much any place on the globe. The world has never seemed smaller, has it? Well, it has. Some 300 to 200 million years ago, we were all one world, literally. Pangaea was a supercontinent that included all of the continents. Its name is in Greek, and it simply means all Earth. But Pangaea started to crack up. The biggest gap formed between the Americas on one side and Europe and Africa on the other. Seawater soon started pouring in, and that's how we got the Atlantic Ocean. This process is by no means over. While you are watching this video, North America is drifting further and further away from Europe at the rate of 1 inch per year. Doesn't seem much when compared to the average human lifespan, but in the end, all the continents will reconnect with each other, forming a supercontinent. And it wouldn't be the first time in Earth history that this happens. Honestly, I'm not going to wait around for that. It's been there for over 3 billion years, but now some of the Earth's oldest crust is falling apart. Today, our continents seem stuck in place, but over a long time, they've moved and shifted around a lot. It's all thanks to tectonic activity, which makes part of Earth's surface slowly slide around like pieces of a giant puzzle. Some of the most stable parts of these puzzle pieces are called cratons. Cratons are super old and strong sections of rock that form the roots of continents and keep them together. The North American Craton is one of them. It makes up a big part of the United States, about half of Canada, and most of Greenland. Scientists have singled out about 35 of these big ancient cratons around the world. They mostly stayed in the same place for hundreds of millions of years because of how strong they are. But in 2014, they discovered that cratons might not be as indestructible as they thought. Some cratons had lost parts of their strong roots because of certain geologic processes and became thinner. It looks like cratons could become less stable if they go through more tectonic changes. In 2024, scientists at China University of Geosciences analyzed an ancient landmass called the North China Craton, or NCC for short. They wanted to learn more about how some of Earth's oldest rock regions can break apart. This process of cratons disintegrating is called decratonization. The NCC is so interesting to study because it has three main parts: the Western Bloc, the Eastern Bloc, and the Trans-North China Orogen, a zone that lies between the two blocks. Scientists found that during the Mesozoic era, the Eastern Bloc lost its deep ancient roots because of the strong Earth movements called tectonomagmatic events. So scientists wanted to see exactly how the processes in the mantle and the movements of Earth's plates led to the breaking down of the NCC. They created 4D models showing how the NCC's shape changed over time, including its surface shape, how its layers stretched, and the way earthquake waves moved through it. They found that a section of the tectonic plate slid beneath the craton and then began to roll back. This rolling and stretching made the strong rock thin out and eventually lose stability. All this started around 200 million years ago, back during the Jurassic period, when dinosaurs were rocking the world. The North China Craton isn't the only place where this decratonization process can happen. Other cratons, like those in North America, South America, and China's Yangtze region, may have gone through similar changes. Scientists say this shows how the continents on Earth have slowly changed and evolved over billions of years. And it looks like, when it comes to geology, there's no place that is 100% safe from changes, but it's no cause for alarm. You don't notice this, but our planet never stops moving and is perfectly normal. But sometimes, this movement still brings dramatic changes. In 2017, scientists made an official announcement that Zealandia can be called a new continent. The continental shelves of this mysterious continent are lying at a depth of around 3,280 feet below sea level. The nearest oceanic crust dives even deeper, at 9,800 feet below that. Geologists have gone deep down to collect rocks from the ocean floor. They have found that, unlike the nearby oceanic crust, which is made up of fresh basaltic rocks, the crust around New Zealand is a mix of ancient granite, limestone, and sandstone. All this screams continental crust. Plus, scientists have discovered a narrow strip of oceanic crust that separates Australia from the hidden land of Zealandia. It means these two are separate continents. 85 million years ago, Zealandia decided to break free from the supercontinent Gondwana. Millions of years later, the mighty Pacific Plate, the heavyweight champion of tectonic plates, decided to take a dive beneath Zealandia's continental crust. And that's how the root of Zealandia, that connection to its continental crust, broke off and went into the depths below. And that's not all the tectonic news from this part of the world. 120 million years ago, Australia and Antarctica were a single piece of land. They went their separate ways, but Antarctica didn't leave empty-handed. Today, there's an oceanic plateau in the Indian Ocean. Long ago, it was connected to another lost continent, the Kerguelen microcontinent. Scientists believe that it made a land bridge between India and Antarctica. To find out what it was like, we can look at a tiny archipelago in the southern Indian Ocean. These islands are all that is left of the ancient landmass. They have a cold climate and feature glaciers because they're so close to Antarctica. But in the past, the weather here must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that live in tropical regions today. Another lost and found continent isn't hiding in the ocean, but under Europe. It's called Greater Adria, and it collided with Europe and started to sink under it around 100 million years ago. Today it lies beneath Italy, Greece, and the Balkans. Its size and even shape match that of Greenland, the world's largest island. Greater Adria is no longer visible, but it left some clues. Part of it was embedded in the Alps. The other chunks are part of present-day Italy and Croatia, on the other side of the Adriatic Sea. Limestone rocks from the former continent started to change once they were under the European landmass. Great heat and pressure spread over tens of millions of years changed their structure. And that's when the limestone left the chat and the marble took its place. Greater Adria wasn't a solid piece of land like the big continent we see today, but more like a giant shallow shelf underwater. Over time, sand, mud, and other stuff settled on this shelf and slowly turned into rock. Greater Adria might have been a little like Zealandia or the Florida Keys, a chain of small islands sitting in a shallow sea. Above the water, there were probably lots of little islands and archipelagos, and beneath the waves, there were colorful coral reefs filled with marine life. If you lived back then and had a scuba tank, it would have been an amazing place to dive and explore. So, with all the things going on with the Cratons, who knows? We could see a new continent in the future. Plus, studying the Earth's crust even deeper can change history as we know it. Scientists in Copenhagen have made an amazing discovery about the real birthplace of Scandinavia, and it's not where we thought. After studying sand and rock from remote parts of Finland, they found out that Scandinavia's roots actually came from Greenland over 3.75 billion years ago. This means the area where Nordic countries are now is 250 million years older than the scientists had previously believed. And we now know, thanks to the tiny crystals called zircons found in Finnish river sands. When scientists looked closely at their chemical makeup, they realized the age of crystals matched the rocks found in Greenland, not Scandinavia. They used special techniques to analyze elements like uranium, lead, lithium, and hafnium, and discovered that Scandinavia's rocky base most likely broke off from Greenland billions of years ago. A small seed of land probably started drifting across the Earth's surface over hundreds of millions of years. This piece eventually settled where Finland is today. Over time, new layers of rock formed around this seed and slowly turned into the Scandinavia we see on maps now. The same study could help us rethink how the continents on Earth first formed. The most accepted theory is that the continental crust began growing right when the planet was formed. But new studies show that the signs of continents only started growing a billion years later. The scientists explain that Earth's continents may have begun as tiny seeds of ancient crust in different places. These seeds grew over time, forming the landmasses we know today. These ancient seeds aren't just found in Scandinavia, but also in Australia, South Africa, and India. Scientists aren't sure if all these seeds came from the same place or if they grew separately in different parts of the world. So there's still a lot to learn, and scientists need to keep digging to figure out if all these ancient seeds are related to each other. Here on our good old planet Earth, water is literally everywhere. Not only in the oceans and seas, but also in the atmosphere, in the ground, and even in our cells. It covers as much as 71% of the surface of our planet. Looks like our planet should have been called water and not Earth. But what would happen if water and land were distributed equally? What if half of the planet became land and the other half was water? Well, let's find out. First of all, let's discuss what we mean by equally. Despite all the things mentioned earlier, there's actually not so much water on our planet. Yeah, if you collected it all in one giant drop, it'd be slightly larger than the United States in size. And all this amount of water would only be 0.02% of the total mass of Earth. So, it turns out that all these horrifying unexplored ocean depths are basically nothing. And now, just imagine if we changed the composition of our planet by leveling the volume of water and land. What would happen then? Then, we'd get a very creepy ocean planet. The planet would look like one boundless ocean. It'd be very unlikely that you'd find even a couple of small islands on it. And if you did find them, they'd probably be the tops of huge underwater mountains. This world would be practically uninhabitable. If you were on its surface, you wouldn't be able to see the sun or anything else in the sky. You wouldn't know what time of day it is or where exactly you are, all because of the incredibly thick fog and clouds. This kind of weather would be permanent on such a planet. Moreover, you wouldn't even understand where the fog ends and the water begins, all because the humidity would be that high. But could there still be life? Well, maybe inside the ocean itself? Unfortunately, this is also quite unlikely. You see, to get to the bottom of this ocean, you'd have to swim vertically down, not for several hours, but for several days. And even after such a journey, you wouldn't see the bottom yet. The ocean wouldn't be bottomless, of course, but the seabed would consist mainly of very hard, impenetrable ice. But not the kind of ice we're used to. This ice would be exotic. There are different types of it, called Ice 5, Ice 6, and so on. Usually, these types of ice aren't as cold as regular ice and may not melt even at high temperatures. And there would be almost no algae or anything like that. So fish would simply have nothing to eat. That's why, if life appeared on such a planet, it would be a miracle. This life would have to withstand a pressure of more than 20,000 Earth atmospheres. Even the most horrifying monsters from the Mariana Trench would be nothing in comparison to the creatures you'd find on this ocean planet. But could we, humans, live there? Well, theoretically, yes, but it would be extremely hard. We could create something like giant underwater stations, but we would still have thousands of problems. Where to get food and other resources, how to repair stuff, and so on. So it would be far from the best option. Okay, now we know that an ocean planet doesn't sound too endearing. What about another option? What would happen if the surface of the Earth was 50% water and 50% land? For this to happen, we'd need to reduce the current amount of water from 71 to 50%. In this case, the sea level would drop by about 2 miles, and a quarter of our planet would become dry land. Although it doesn't sound like much, the consequences would be disastrous. Right now, there are 5 interconnected oceans on Earth: Atlantic, Indian, Pacific, Southern, and Arctic. But if we lowered the sea level, all these oceans would simply disappear. They'd turn into separate closed reservoirs and seas. On the contrary, all the continents would merge into one giant landmass, almost as if we swapped the land and water. At first, it would seem pretty cool. Now, you could literally walk around the world. However, the amount of land you'd have to travel would also increase. Every continent on the planet would grow in size. All this new territory would be approximately equal to the current area of Asia, Europe, Africa, and North America combined. Well, that would be a huge mass of unused space. But what would we find on these new territories? Most of them would be pretty flat. But in places where there used to be deep oceans, you would see vast corridors and steep crevices. Now, here's another cool thing. Most of the sunken cities would return to the surface. And no, unfortunately, we wouldn't find Atlantis among them. But there would still be a lot of other cool places. For example, the ancient Roman city of Baia, which, according to legends, was basically a paradise on Earth with all its luxurious villas and gardens. Or Heraklion, the city that went under the sea thousands of years ago and was considered a myth for a long time. So yeah, we could organize tours to these ancient places. But of course, not everything would be fun and games in such a world. Due to a severe loss of water, ocean currents would be disrupted, and this would lead to very serious climate problems. The ocean absorbs the heat radiated by the sun. Thanks to the currents, this heat is distributed all over Earth, which creates a stable and pleasant climate. But if these currents were disrupted, then the temperatures on Earth would become more extreme. It would get much hotter near the equator and even colder around the North and South poles. So yeah, unfortunately, the Antarctic ice wouldn't save us. It would be quite the opposite. The regions around the North and South Poles would completely dry out, basically turning into dry, cold deserts. In addition to heat, water also absorbs carbon dioxide from the air, and since the oceans wouldn't be able to absorb it, this gas would begin to accumulate in the atmosphere. This poisonous excess would cover the entire planet. The average temperatures would increase, and the whole planet would start to dry out slowly. Massive forest fires would break out, and so on. Sound familiar? Now, to make matters worse, there would be nothing to extinguish these fires, because, rains can't form from nothing. So yeah, the precipitation levels would fall, and this would lead to dangerous droughts. We'd get a bunch of new deserts on all the continents. Despite getting all those new territories, it's unlikely that we could somehow build new cities and towns there. Many of these territories would be uninhabitable, not only because many forests and plants would disappear, but also because most animals would migrate to more pleasant places. As a result, we would have great difficulty finding any food at all. So, all life on our planet, plants, animals, and people, would have to adapt to new living conditions. They would have to evolve quickly and get used to the constant shortage of water. Animals, for example, could shrink in size because of this. Many of them, due to the lack of grass and moisture, would switch to a strictly carnivorous diet. And of course, we would have to say goodbye to the huge abundance of marine life. Many fish would disappear forever. Humans, most likely, would make a big evolutionary step backward. Not only because we would lose a large number of resources and move to new territories, but also because we would also lose access to one of the most important sources of energy in the world, hydroelectric power. Without electricity, many factories would stop working. To say that this would cause a large-scale crisis for us all is sadly obvious. So, our current ratio of water and land is the best possible option. If there was too little or too much water, the consequences would be awful. That's why we need to protect the current conditions with all of our might. So get this, Taylor Swift takes a flight from Los Angeles to Tokyo that leaves at 10 a.m. on February 20th. She's on the plane for 12 hours, but she lands only at 2 p.m. the next day in Tokyo. That's a 28-hour difference. So, how did this time warp happen? Well, it's all because of this wonky line. This is the International Date Line. You know, that imaginary line that slices the globe in half and decides who gets to celebrate the new year first? It's the Line Islands, by the way. But crossing this line doesn't just make you feel like you've stepped into a transporter. It actually changes your day. Cross from east to west and boom, it's 24 hours later. If you travel in the opposite direction, crossing the line from the western side to the eastern side, you go back an entire calendar day. Now, you'd think that the International Date Line would be a nice, neat, straight line in the ocean where the time zones switch. But in reality, it's as if someone took a ruler and said, let's make this complicated. The line zigzags all over the place, wrapping around islands and causing all sorts of head-scratching confusion. For instance, Big Diomede Island and Little Diomede Island are only 2.5 miles apart, but have a 21-hour time difference. And things can get a little more complicated depending on which time zone a country follows. For example, if you travel 659 miles across the date line from Baker Island to Tokelau, you must add 25 hours. In other words, that's 1 day and 1 hour. And if that doesn't sound weird enough for you, wait, it gets crazier. When it's 6 o'clock in the morning on Thursday in New York, it's still Wednesday night in American Samoa. Meanwhile, over in Kiribati, it's already Friday. Yep, we're talking about 3 different calendar days happening at the same time because of this one imaginary crazy line. This phenomenon occurs every day between 10 o'clock and 10:59 in the morning. So, why does the International Date Line look so ridiculous in the first place? Well, great question. Although these zigzags may seem completely arbitrary, they actually have a logical basis. It's pretty much a made-up concept based on the Earth's rotation. The Earth is always spinning, thank goodness, and it takes about 24 hours, or a day, to complete one full rotation. To keep things in sync, people took the Earth and divided it into 24 time zones, each 15 degrees apart. But what is the starting point for a day on Earth? Well, basically, people needed to figure out which of these 24 zones or lines would be the starting line, or the chronocenter. They needed a reference point, a line where they could begin adding or subtracting time as you move east or west. That line is what we now call the prime meridian. But here's the catch. Deciding where to put this starting line, the prime meridian, is totally arbitrary. The idea of establishing a line where days begin and end goes all the way back to at least the 1300s. Back then, map makers were doing their own thing, picking their own east-west dividing lines called meridians, which, by the way, is just a fancy Latin word for midday. Without a universal standard for when a day officially started or ended, sailors on long voyages just had to wing it, figuring out how to handle the time they were gaining or losing along the way. So, in 1884, people decided to organize this whole mess. 25 nations gathered at the prestigious International Meridian Conference in the United States with one big goal: to decide on a line that would serve as the official prime meridian. Finally, like it or not, they were determined to create the international dateline that the whole world would accept and would follow from that point forward. The prime meridian was established in Greenwich, England, and the international dateline was placed on the opposite side, running through the 180th meridian. Well, sounds simple, right? But that's when the nightmare really began. The chosen international dateline didn't just wander through uninhabited areas. Oh no! It split some countries in half and created all sorts of chaos. I mean, if you divide the world with a completely straight vertical line, you end up with situations where half of a country is one day ahead and the other half is one day behind. Take Kiribati, for example. The country is primarily centered in the Gilbert Islands, which sits just west of the international dateline. However, in 1979, their territory got a little bigger with the Phoenix and Line Islands, which are way east of the dateline. Suddenly, Kiribati was straddling the international dateline. This created a bit of a headache for businesses. Folks on either side could only communicate by radio or phone for 4 weekdays a week. Now, to fix this quirky situation, Kiribati decided to skip Saturday, December 31st, 1994, right off the calendar. So Friday, December 30th, turned into Sunday, January 1st, 1995. And just like that, New Year's Day came a day early. Woohoo! After that, the dateline moved eastward to go around the entire country. So the same thing that happened to Kiribati happened to other countries as well. For example, when they got to the Aleutian Islands in Alaska, the line made another detour to include them. And when they got south of the equator, well, guess what? Another eastward bend to cover even more islands. And that's pretty much why the straight line started to get a bit ziggy-zaggy. This wonky line is designed to avoid land as much as possible, so there's less hassle when it comes to changing days. So, no, you can't stand between the international dateline, like having one foot in one day and the other in the next. But you can cross it by boat. In fact, some fancy trans-Pacific cruises even offer a time travel package for adventurous travelers who want to cross the line and jump into the future. Now, in the end, the international dateline looks this ridiculous because it was constructed based on a series of arbitrary decisions, historical quirks, and a whole lot of confusion. But it's not just because people organized it in the 19th century that there is no confusion regarding time zones today. Another thing that the prime meridian establishes is Coordinated Universal Time, the famous UTC. Now, UTC never changes for daylight savings time or anything else. However, in 1908, Canada decided to spice things up by creating Daylight Saving Time, or DST. Their idea was to set the clocks 1 hour ahead of standard time to make better use of sunlight in the spring and summer and fall evenings. The idea was so brilliant that most countries jumped on board, but not everyone. Just look at Nepal. They have never ever used the daylight savings time, which means their clocks do not change throughout the entire year. As you probably know, countries with large territories often have more than one time zone. Just like the United States, which has 11 time zones. Australia has 9, while India is a special case. Look, India is a big country with an area that stretches around 1,800 miles from west to east. So it should have 3 time zones in total, but they only have 1. This means that the sun rises almost 90 minutes earlier in Dong in the Far East than in Guharmoti in the West. And why do they have only one time zone? Well, basically, because they can. Just remember that the international dateline and time zones are invisible, artificial, and now you know, totally arbitrary. So if a country wants to stick with just one time zone to simplify processes and business operations within its border, then hey, why not?
You could wake up in New York, grab a bagel for breakfast, hop on a train, and by lunchtime, you'd already be in London, enjoying fish and chips. What sounds like every tourist's dream could be a reality soon. Right now, traveling between these two cities usually takes about 8 endless hours by plane. But a high-speed train zipping through a massive transatlantic tunnel could make the same journey in just 54 minutes. The plan is to construct this train beneath the Atlantic Ocean, so the stations would look like those trendy underwater restaurants. Not only would you get to Europe in record time, but you wouldn't have to deal with jet lag or feel sick from turbulence. So far, this mega project sounds amazing, but can we really pull this off? Well, that's the million-dollar question. Actually, it's more like a $20 trillion question. That's how much this train and its futuristic underwater stations would cost. It's hard to imagine anyone having enough money to construct it, so specialists thought it was out of the question. But people started feeling hopeful again when Elon Musk dropped this announcement. He said not only is this kind of transportation possible, but his company could make it happen for 1,000 times less than everyone thought. Traveling between New York and London in less than an hour means the train would have to hit a jaw-dropping speed of 3,000 miles per hour. Yep, 3,000. That's about 5 times faster than the cruising speed of a commercial airplane like a Boeing 747. So, how is this even possible? Well, it's not an average tunnel. We're talking about a vacuum-sealed tube underwater, which cuts out air resistance, letting trains zip through at insane speeds. And it's not just any train. It's more like a high-tech aerodynamic capsule that levitates and moves thanks to magnetic propulsion. At least that's what experts think, since this kind of technology is already in use today with the fastest public train in the world, the Shanghai Maglev. This machine runs in China and hits a top speed of 186 miles per hour. What's crazy is that its locomotives are not even touching the tracks. They're literally levitating and floating just about 0.4 inches above the ground. This line takes people from Shanghai to Pudong International Airport, so travelers don't have to worry about traffic and can get to their flights super fast. This cutting-edge technology makes a 19-mile trip take just 8 minutes and 10 seconds. With a regular train, that same journey would be about 4 times longer. Back in 2001, people worked hard over 2 years to construct the maglev train, and they also spent a lot of money, as the whole project cost over $1 billion. Despite that crazy initial price tag, keeping this line running is not as expensive as it might seem. It's actually cheaper to operate than regular trains. Since the maglev doesn't touch the tracks, that means a lot less wear and tear and way lower maintenance costs. On top of that, its propulsion system is impressively energy efficient. As we've already mentioned, this is the fastest operational train in the world, but China isn't stopping there. They're likely to break their own record soon, having already unveiled a prototype of their next generation train, the CR450. This sleek silver bullet had reached test speeds as high as 281 miles. If this project comes to life, if people really start using it on a daily basis, it will be a game changer for high-speed rail. And it could shrink the journey between Beijing and Shanghai to less than 3 hours. That's like 1 hour less than what people take when traveling on today's high-speed train. Now, the team just needs to run a couple more tests to ensure it meets all necessary standards for commercial operations. This car looks like a Batmobile, and it's probably just as powerful. Say hello to the amazing Koenigsegg Jesko Absolute. Its sleek, futuristic design isn't just for show. Every detail on this machine was crafted to cut through air with precision, reducing drag and turbulence while boosting its high-speed performance. Experts ran the first computer simulations, and the Jesco Absolute hit an astonishing 311 miles per hour. But the team is positive that it can go even faster. This beast comes close to the cruising speed of small jets, and because of that, it smashed all records and became the fastest car in the world. When you visit the Coventry Transport Museum in England, you'll come face to face with a terrestrial vehicle that looks more like a rocket than a car. Meet the Bloodhound LSR. It's been on display since 2019, right after hitting 628 miles per hour during tests in South Africa's Kalahari Desert. But the team behind this vehicle isn't satisfied just yet, and they're 99% sure they can go even faster. So, they're planning to bring it back to the track soon, aiming to smash another record. But there's a catch. The team is still looking for a fearless, skilled pilot who can handle speeds over 800 miles per hour. And before you rush to sign up for the challenge, let me remind you, it's going to take more than just guts. You will need a major sponsorship deal too, because getting back this vehicle on the track and breaking that land speed record could cost around $15 million. If you're curious about the fastest jets in the world, look no further. Meet the North American X-15, a legendary aircraft that flew for nearly 10 years and set an unofficial world speed record of 4,520 miles per hour. This beast is so impressive that it actually reached the edge of space during its test flights in the 1960s. Yep, astronauts territory. To put that into perspective, commercial airplanes, like the ones we fly in, usually travel at altitudes of up to 42,000 feet, but the X-15 soared more than 354,000 feet. Now, imagine flying faster than ever before, zooming through the sky at over 5 times the speed of sound. That's exactly what NASA did with this revolutionary aircraft, known as the X-43A. This airplane is scramjet powered, which basically means it's an engine that operates at a supersonic level. I mean, it doesn't have any moving parts like regular jet engines do, like turbines. Instead, it uses the plane's speed to push air into the engine. The air gets compressed or squished by the plane's fast motion, then mixed with fuel and burned to produce thrust. For non-experts, this might seem crazy, even dangerous. In fact, we should mention that the first flights of the X-43A weren't exactly smooth sailing. The initial attempt happened back in June of 2001, but the airplane was destroyed after the booster rocket went out of control. Thankfully, the second and third attempts were a huge success, with record-breaking flights that made history. I know elevators aren't the first thing that comes to mind when we think about super-fast means of transportation, but it's only thanks to ultra-modern high-speed elevators that skyscrapers as tall as the Burj Khalifa and Taipei 101 became accessible. One of the fastest elevators in the world is located in the Shanghai Tower in China, which has 128 floors. To get people from the ground floor to the top of the building quickly, the elevator has to move at an incredible speed of 67 feet per second. That's faster than Usain Bolt at his top speed, but just a little slower than a cheetah. Still, it is super fast, about 5 times quicker than the elevators we ride in most buildings. So if you're afraid of heights, speed, and tight spaces, we suggest you avoid going that far. This area might just be the most important spot in America right now, as it is worth over $1 trillion. There's something incredibly valuable hidden right here at Thacker Pass, and it is going to shake things up, not just in Nevada, but in the US economy and its global relations. The McDermott Caldera is a massive area, about 28 miles long by 22 miles wide, stretching across northern Nevada and southern Oregon. It's in Humboldt County, a quiet, rural place with just one main city that's going to change a lot in the next 5 to 10 years. That's because they found white gold there. We're talking about lithium. And to explain why this metal is so important, we need a scale. On one side, we place a chunk of lithium, and on the other, an apple. What do you think will happen? If both have the same volume, the scale is going to tip toward the apple. That's because lithium is super light. Its density is about 0.3 ounces per cubic inch, which makes it the lightest solid you can find at room temperature. Lithium is also extremely reactive. That means it combines with other elements very easily, and it can catch fire just as easily. Mix it with water, fire. Expose it to air, yep, fire again. But when you combine its lightness with its high reactivity, you get a material that's perfect for batteries. Like the one powering your smartphone, laptop, or even your electric car. Nevada's been hiding this treasure for about 16 million years. The McDermott caldera used to be a volcanic hotspot, spewing molten rock and creating a huge lake filled with mineral-rich waters. Over time, that lake dried up, leaving behind thick layers of clay loaded with lithium. Right now, Thacker Pass Mine is sitting on one of the biggest untapped lithium reserves in the world, worth about $1.5 trillion. If everything goes as planned, they expect it to produce about 40,000 tons of high-quality lithium a year. And that's enough to make batteries for up to 800,000 electric cars. Like I mentioned earlier, this metal is the backbone of modern batteries. And with the world racing toward green energy, the demand for lithium is skyrocketing. Since 2020, its price has gone up more than 10 times, making it the most expensive battery metal in the world. That means it's way more expensive than magnesium, nickel, cobalt, and other materials used in rechargeable batteries. Right now, we're using about 1.16 million tons of lithium per year, and roughly 85% of it goes into making batteries, mostly for cars. Between 2030 and 2040, experts think we will need to double the money we're putting into production, from $94 billion to $188 billion. At the same time, investment in batteries will jump by over 200%, reaching $686 billion. Finally, by 2050, the demand for lithium is expected to be more than 10 times higher than what we're producing now. Sorry, I know that's a lot of numbers, but I just want to show how important Thacker Pass will be for the whole world. This mine is going to be key to keeping everything running. I mean, literally, since most of the future demand will be for things like cars, electric bikes, scooters, and renewable energy storage. Nevada could also be the epicenter of a global energy revolution, with the US aiming to cut pollution by 50% by 2030. A big part of that is replacing gas-powered vehicles with electric ones. And to make that happen, America is going to need a whole lot more lithium than it's producing right now. Nowadays, most of the metal used in the United States come from countries like Chile and Argentina. So if America wants to be a leader in this market, it really needs to invest more and more in projects like Thacker Pass. But there's another challenge. Finding lithium in a mine is one thing, but refining it is another story. Just like diamonds are carefully cut and shaped to bring out their sparkle and sold in rings and necklaces, something similar needs to be done with lithium. The raw material that comes from the mines has to be refined into a pure form that can actually be used in things like batteries. And China pretty much dominates this part of the market, and they're responsible for about 75% of global lithium-ion battery production. In other words, it doesn't matter if a country finds this powerful metal on its land, it will probably still need China to help refine it. So, the US is eager to strengthen its supply chain. In fact, they're so excited about this possibility that authorities have invested over $2 billion in loans into the Nevada project. Because of that, Thacker Pass could make the US a leader in lithium production worldwide. If their estimates are right, the McDermott caldera could hold nearly half of the world's known lithium reserves. It would almost double the reserves found in Bolivia's salt flats, for example, which used to hold the record for the world's largest deposit. This discovery is about to change Humboldt County for good. Those quiet streets surrounded by nature will never feel the same again. the mine will need about 2,000 workers who will probably move there from other cities. Those workers will need houses, hospitals, schools for their kids, and all the necessary services. Do you see how it's like a ripple effect? For every person hired to work on the project during construction, 6 more people will get hired in the state to support them. Thacker Pass is also going to have a huge impact on the economy, not just in Nevada, but all across the country. People expect the mine to be active for 35 years, and each year it's expected to generate over $2 billion. But here's the thing. In Thacker Pass, they'll be extracting lithium from clay, and this process has never been done on such a huge scale before. So it's kind of a hit or miss. But if it works, it could completely change the industry. Big question. Who's interested in all this? Well, we've got 3 big companies eyeing the lithium market in the US. First, there's ExxonMobil. The oil giant wants to start producing lithium by 2027, and they have plans to become the top supplier for electric vehicles by 2030. Then there's General Motors, the company behind big car brands like Chevrolet and Cadillac. They're so interested in this business that they agreed to pay $625 million for a 38% stake in Thacker Pass. And finally, Tesla. In 2023, they started building a factory in Texas to process lithium. It's all part of their plan to handle more of their supply chain themselves. Now that you know how important lithium is, you might be wondering, what if we run out? Well, that could happen, since it comes from mining and, just like gold, is a finite resource. But that doesn't mean we'd have to give up smartphones or electric cars. If we ever run out of this metal, we'd probably find new ways to produce batteries. In fact, some experts think thermal batteries could be the next big thing. They store extra energy from renewable resources like wind or solar power, which are very cheap. So they represent a new way of storing energy at a small fraction of the cost. Nowadays, they're primarily used for powering the production of steel, cement, and chemicals. Thermal batteries are also being used to heat and cool large buildings. However, more and more projects are focusing on bringing this technology into private spaces, like houses and apartments. Experts are optimistic that initiatives like these could make thermal batteries as well known as electric batteries, and they might soon become a regular part of our daily lives.